Good morning. It's Thursday morning in Hong Kong, and at last we've got the paralleling working for the three-phase, so it's now functioning. So we set it up. We've got two three-phase inverters set up here together. For your information, you can see the version here. I'm not going to read it all through, but I'll put it up on the website. So is the version of the MCU and the comms, everything else. It's a little bit different to the other inverters. So you can see the version. We've upgraded it. It's now available. Everything's functioning. The only thing not functioning is the gem port. We're a couple more weeks just testing, but if you're not using the gem port, everything else is working fine. So we've got two inverters set up together. We've updated them to the latest software. We've connected to a three-phase AC. As I said, be careful. If you're not a fully qualified electrical engineer, do not touch this. This is dangerous. I keep telling everybody. We've got the CT coils on the supply coming in. It looks a bit of a rat's nest, but it's only a demonstration. So we've got the CT coils here and the phase rotation meter. So we can see the phase coming in. We can see the phase rotation is running perfectly fine. So it's all good. If we look at the two screens are mirroring each other, and if we go onto you can see the flow, and you can see everything is in the three-phase, and everything is actually mirroring. So let's see, without further ado, let's put some loading on it. So I'm going to put a loading on here. So this is an incandescent load, and this is a motor. So we've now got a three-phase motor running, and we've got an incandescent load. There we go. So you can see perfect phase rotation. So of course it's got perfect phase rotation because it's running a motor, and the motor's not pouring with smoke. So we know it's working fine. Two inverters in parallel. The only thing is we've got the comms. You know how to set this thing up, exactly the same as before. We go into advanced setting, multi-inverter. We select one is the master, okay, and one. So master I put as Modbus 1, and the other one we set it up as a slave. We go on to advanced setting, multi-inverter, slave, Modbus 2, both clicked in parallel. Also, make sure you've got good communications with your battery. If you haven't got communication with the battery, it won't work. The communication with the battery only functions on the master. So we've gone in here, you see I've only got a small battery and it's communicating fine. The other one won't show communication, but it will show the information. So it's in fact the battery is at 100%, and you can see it showing 100%. So everything's mirroring, but the BMS will only function on the master. So everything's mirroring. Okay, so let's turn off the AC, and we're now going to go to battery. So flick the AC off. We're now instantaneously fully synchronized. Nothing happens to the motor. Perfect. We're now running on battery. So the thing is now running on battery. Two inverters working in parallel. They're both delivering 490 watts each. 490. So you can see there's a slight discrepancy in the values. That's normal. That's due to some tolerances and cable lengths, etc. But apart from that, everything is working perfect. So we have now got paralleling three-phase inverters. So let's see, it's quite special. We're not sure. Don't forget, the other thing is we also do asymmetrical load. So you can also asymmetrical, but the asymmetrical load is more when you're using for the standalone inverter. When you're putting more in parallel, it will do asymmetrical load to a certain extent. But be careful your cable sizes, be careful your battery sizes, because there's much more power in this. So it's a beautiful piece of kit. And also don't forget, it's a 1000 volt MPPT, and one MPPT, it's got two MPPTs, so we use all the latest solar panels. So there you have it. Three-phase paralleling, working perfect. So thank you for watching. Choose smart energy.